Alright guys, welcome to the complete microservices course in Go, where we're going to build a complete order management system from scratch using the standards library as much as possible, whilst using the best industry tools for building distributed cloud systems. For example, we're going to use RabbitMQ as our message broker, where we're going to have asynchronous communication between our services, as well as we're going to use gRPC for that. We'll delve into the world of observability, reliability. We'll be having distributed tracing in our system, as well as we're going to have service discovery between all of the services. On top of that, we're also going to implement retry mechanisms, dead letter queues on all of our services, so that we make sure that our customers get their order delivered. And who is this course for? This is for everyone, honestly, but you must be knowledgeable with Golang and you must be interested in building distributed systems in Go. Either you are completely new to it or your team is using microservices at work and you want to catch up quickly, then it should be fine. Now, in this project, I have decided to go as bare bones as possible, meaning that we're not going to use any frameworks or any microservice frameworks like Go Micro or Go Kits. For example, we're even going to implement our own service discovery on the clients by using HashiCorp's console, because I want you to learn, I want you to implement these things by yourself, because we're going to go as bare bones as possible because of that. After that, you can go and implement anything you like on any framework, on any tool, because you know the fundamentals, and this is what I want to give you on this course. But only after you learn the fundamentals that you can use those tools. That will make your code more pretty, yes, because we are going to get our hands dirty. We're gonna be writing verbose code sometimes, but you gotta get your hands dirty before you build a castle, right? And just a side note, if you're watching this on school, you'll have free access to future updates and addendums on the course, which will be happening. And if you're wondering what the school community is, it's this premium community that we are building. It's premiering today with the course. And the reason I've decided to make this platform, it's because I don't like how normal courses are just put online with static video and the people taking it are just left alone. They have no contact with the instructor nor the other members taking the course, while most of the times the course itself doesn't even receive updates. And so this is the reason why I've decided to make this school community that solves all of those problems and includes some additional features like gamification. You can have a leaderboard, you can level up inside of the community and get additional perks. You can get to have Q&A calls, weekly Q&A calls with me and the members of the community, and basically every week this is changing, we're adding new features, and I'll be pretty much working on this community every day, part-time, so you'll have access to my current wife's work, to my future wife's work, just for 1/10 of the price of a normal course. And basically this is the place to be as an engineer if you want to level up. Now I just want to make a quick preface for YouTube, because this is not the full version of the course you're watching. This is just a third or something like that of the course. The full version is on school. I've decided to make this free for you on YouTube because I want to give you this as a token of gratitude for the support of everyone that has been given on the last couple of months. However, I've made the community fee accessible for everyone, so there is no excuse for you to not level up as an engineer. So grab the full version, scroll down the video, and it is the top link on the description below. And a little bit about myself. My name is Tiago and I work as a software engineer. I'm a full-time software engineer, and on the side I run this YouTube channel that you probably know me from. You might not know this, but I'm a self-taught engineer, meaning that I didn't go to university or anything like that to get my job as an engineer. Everything I learned was self-studied, and I got my first job as an engineer when I was just 19 years old. At the time I had the tough choice of either working on a shitty job that I didn't like, or self-study for 6 months on something that I really enjoyed and that I was already doing in my teens. I had built a couple of games in Unity, so that was a no-brainer decision for me and a leap of faith. And so I grinded like a maniac and I got my first dream job. And I remember that at the time it was not easy. I had no confidence if all of this work was going to even work out. And I know that some of you might be in this position as well, that you might feel the same as I was. And yeah, this was pretty much half a decade ago. And since then I know exactly what I would have done differently. I have helped a couple of friends do the same. And I know exactly today what works and what doesn't work if you want to get into this field as a software engineer. And this is one of the reasons I have created this community at all, because at the time I had no idea how to actually do this. I was lucky because I was in a community that I actually got help from, and this is how I got referred to the job that I got. And this is really the power of communities that courses do not give you. And yeah, this was just a quick intro about myself. Let's now go to the microservices course, which is the reason why you have come here. So what are we going to be building? Basically, it's going to be an order management system. So imagine you go to McDonald's, and basically this is going to be us. So with this little guy, and you go to McDonald's and you have those big point of service screen all over the place. Basically, you come to this is going to be like the gateway, and you ask for example, get me a Happy Meal, because we are broke and we can only afford a Happy Meal. And basically what happens behind the scenes is that this point of service, the gateway, is going to communicate with the rest of the services. For example, it's going to reach out to the order service, where it's going to first check if there's enough stock, and then we're going to communicate with the payment service and get the payment details. After the payments are done, basically we grab ourselves, and basically before this, actually, we get, for example, let's say we get this receipt. Imagine this is the receipt you get with your order ready, and basically you go to the order or to the queue, and you wait for the kitchen service or the kitchen staff to cook your burger. So here they are, and after your order has been completed, imagine this is going to be your Happy Meal. You get your Happy Meal and you're happy, and all is done. So basically this is what you're going to be building. Instead of flipping burgers, you're going to be building the whole McDonald's system in Go. Now let me quickly show you what I was talking about. So here we're going to create an order with the full system running, so we can have an idea of what we're going to be building. So here are the services running. Basically, I'm going to go here to the my VS Code. Here I have an HTTP terminal or a program that I can make HTTP requests. So we're going to hit the gateway service. Basically, going to create an order with these following items. So it's 2 items with multiple quantities. Here I have basically multiple quantities for the same item. You're going to see that they're going to be combined into one. And if we hit send, here we have our order ID. I'm going to copy that, and the status of the order is pending, and here are the items listed. Now we have a URL that basically, if you go to the browser and paste this in, here is the UI. So this is going to be a very simple UI because this is a backend focused course. But in the future, in the coming weeks, I'm actually working on the full stack version of this course. We're going to be building the whole front ends with HTMX and React as well. So if you are on the school community, you're going to basically get this course for free there. So let's continue with the payment. We are basically redirected to Stripe, where we can create our order. So here I have the quantity and the price for the potato chips, and here is the burger with a lot of cheese in it. So let me just put some random email here, because this is the test mode for the payments. I'm going to put just something here, can be Thiago, and I'm going to pay. Basically, behind the scenes, the Stripe webhook is going to catch up, going to redirect to our system, and now the order has been placed. You just need to wait. And as you can see, the order has just been prepared, it has been cooked, and all we need to do is, you'd imagine we'd print these receipts, and we would go grab our order at the queue. So this is pretty much the whole flow. I'm going to show you a bit of the instrumentation behind, so you can see the life cycle of the create order request and how everything works behind the scenes. So here I have both the console UI and the MongoDB Express. Basically, console is going to be it's basically HashiCorp console. It's from HashiCorp. This is the service discovery tool that we're going to use to monitor our services. As you can see, these are the services. Ignore these 13 instances of the services. This was a test that we're going to be doing. Then here on the MongoDB, this is basically NoSQL database. I think you're probably familiar with it. And this is the order that we have just created. The status is ready, and this is the backlog of the items that we have ordered. So basically, one of the services already deleted this payment link from here as well. Then here on the RabbitMQ UI, everything is fine. We have here that letter Q as well. So if any message doesn't get delivered, we have a retry mechanism on all of the services as well. But as you can see, the whole flow worked and it's healthy. Then here on the Jaeger UI, I basically want to show you the traces. So if you go here, this is the first one that we did. So it has these 7 spans. As you can see, this is the first flow where we created the order until it created the payment link. So this is from us hitting the HTTP until it went to the order service. Then the order service requested the via gRPC to the stock service. And then at the end, we have the payment service, which created an event for the Rabbit MQ broker with an order created event. Then we have these are the GET requests. And if you come here to the system architecture, you can actually see a graph of everything that happened with the number of requests. So you can see here the flow of everything that we have done so far. And this is pretty much it, guys. I just wanted to give you a quick heads up and a quick overview of what you're going to be building, so you know what this course is all about. So let's first understand a bit the theory and the motivation behind using microservices in the first place. So what are microservices? So this is an architecture pattern that is a model for organizing systems in a way that they are a collection of multiple services, each of which is responsible for a part of the business logic. So in our example, we have, for example, the payment service, which is responsible for everything related to payments. And then we have the orders, the stock service. Each of these are a piece that complete the whole system as one. Now, if you contrast this to a monolith application, for example, all of those services would be inside one code base, and all of them would be related to one way or another. So they would be coupled. And if, of course, the system requires, that might be the right approach. So is it better to actually divide all applications into multiple services then? Not necessarily, because each project has its own needs, and as with any model and any architecture in software engineering, you need to do a careful analysis and assessments before choosing whatever you need to go. So this really depends on the business needs and requirements. So this is no bulletproof solution. So to understand a bit the motivation behind using microservices, let's actually go back to the monolith system that we are used to building, right? And let's see what are the good things that it has, and then the bad things that it has, so that we can see that microservices might combat some of those problems. So firstly, the monolith architecture is simpler, which is actually good, right? Especially compared to distributed systems, because we don't have to split the whole application into multiple parts. So those parts, those services don't need to communicate with each other. So it makes everything simpler at the end, and also makes the code base smaller and easy to develop, because you have the whole code in one repository. So it's very easy to understand the whole system as one. And as you're going to see in the microservices architecture, that is not really the case. It can be sometimes hard to understand the whole feature because it might encompass multiple service calls. Now, the problem comes to the monolith architecture when at a certain point of time, the application grows so much that it becomes a bottleneck to deploy. So if you have a team that is doing multiple deploys a day, so it's growing a lot, then the deploy might actually take a couple of minutes, 5 to 10 minutes, which if you want to move fast, this is not going to be good. And another thing as well, it's the stability, meaning that if the monolith wants to scale, it's sometimes hard to scale it, because imagine that in our case, the payment service would receive a lot of traffic. We would need to scale the whole thing, so the order service, all of that would need to scale together in order to accommodate for that traffic, which it becomes more expensive and it becomes less reproducible as well. And again, of course, this becomes more predominant as the engineer team grows, and you might need to split teams into multiple domains. So this is where microservices architecture comes, because it can solve some of those problems. For example, the stability problem, as we have seen. If the microservices enable a better horizontal scale, meaning that we can scale multiple services of just one, for example, the orders or the payment can scale more than the other ones depending on load. This, of course, makes the components of the application scale better independently, which can have some cost benefits at the end of the month as well. And as we have seen, this enables the continuous delivery of services, so the continuous delivery and deployment of multiple services. So one team does not depend on another one. It can deploy its service independently of the other one. And because of that, they are more fault tolerant as well. So if in a microservices architecture one service fails, typically it does not affect the whole application. So each service can, of course, operate independently, making it easy to isolate and contain the issues. So this enhances the tolerance and improves the overall system reliability. And in my opinion, one of the best benefits of all of this combined is that it forces us to create smaller services that do one thing and do it very well, just like the Unix philosophy. So at the end of the day, you're gonna have a better code base as well. And very quickly, just one last advantage of the microservices is that by dividing the services into their own worlds, basically it makes easier for large engineering teams to divide themselves, as I have explained, but this also allows them to choose their own tech stack, their own decisions, their own processes into their own services, basically decoupling the whole process from the whole system into their own specific service. Imagine you could have the payment service could be in Rust because we might want it to be efficient, and the other one would be in Go. So you can have that freedom of choosing. With everything in software, microservice architecture, of course, has some drawbacks, and the first one, actually it has some big drawbacks as well, so you need to take that into consideration when adapting it. But the first one is that it is more resource intensive in terms of latency, because multiple services are divided into servers, which then need to communicate with one another, so making it more expensive to communicate with one another. Imagine to create an order, we need to go to the order service and goes to the stock service, to the payment, so there is a couple of round trips just to get you an order prepared. Secondly, they are harder to debug, so as we have seen, because there are multiple services communicating, sometimes it is harder to see the whole flow or pinpoint an issue in the system. And another drawback is consistency. So data is often scattered among multiple services, which makes it better to isolate the service, so it doesn't know of the whole world, just knows about itself and the data it needs to hold. This makes it harder to create atomic operations and transactions, so because the changes need to be done across multiple services, right? Which then leads to the next one, which is a possible duplication of code and data as well. I have not written here, but of data, because we're going to have duplicated data if you want to have multiple data stored. If you have two services and they have their own storage, their own database, you're not going to access the other services database. Usually you have your own database for that. And basically, regarding the code and the features that are going to be duplicated, we're going to partially solve this with the commons package library that we're going to do this in Go. And finally, just to mention one last thing, observability, which, because of course the system is made of multiple services, we need to collect more data, including the traces, the logs, and the metrics, which we are going to do as well in this course. Now, I'm telling you all of this because as a software engineers, we need to be aware, we need to be educated on the drawbacks and the advantages of any decision we make in our company, because we need to advocate to our stakeholders and our team what is the right decision. So we need to know the pros and cons, of course. So in this video, we have covered everything from what is microservices, why would we want to use them, and what are the pros and cons, and we compared it to the monolith typical application structure. So let's understand why Go is a good choice to implement microservices with. Now, let me just say it again, because it's really important before we implement microservices with Go or any other language at all, really. Here we are aiming to be software engineers, thinkers, and not code monkeys. So we need to be able to advocate to our team and our stakeholders what is right and not what is fun for us. This comes with study and practice, of course, and that is one of the reasons I have created this cool community in the first place, so that we can accelerate your progress, so you can learn from everyone in the community, from people that are at your level, from people that are seniors, and basically this is something that is missing from the developer community nowadays, because you see, you are bombarded every day with blog posts, with YouTube videos that are explaining and showing the cool and new technologies out there. But most of the times in the real world, the boring technologies, the ones that power most of the software in the world, the ones that have survived the test of time, those are usually the ones to go. Those are usually the right choices and not what's new and what's popping. And that judgment, this mindset, comes with being at the right space with the right people around you. Now, this relates to microservices because this is a powerful technology that will, of course, make you stand out from the other developers, right? Something complex, distributed systems. But you should be cautious of not introducing microservices too early in your projects. It's usually a better idea to start simple, start small, and then if you need to divide in the future into multiple services, you can do that with your team into logical steps and logical domains. If you do it too early, you might end up with a monolith, a distributed monolith, which is the worst of both cases. And you should also design from the start the system for failure, so you should know that the system will fail, because these are multiple services calling each elf with remote calls. So you need to know that there is very likelihood of something failing and you don't have any clue. So instrumentation tools and observability are very important to go with microservices, and many other things that we will cover from the rest of the course. But now let's go back to this module again, and why would we want to use Go for microservices? Now, of course, Go is the language I like the most and the one that I use all of the time. But if you check the facts, basically we can see that the standard library, you might already know this, right? That the standard library of Go is really powerful for building complex and modern web applications. You have all of the tools out of the box. We don't need to install pretty much anything nowadays. Plus, the language is super simple, so it doesn't have any other bullshit. So this simplicity paired with the fast compilation times that we can have, basically you can compile our applications into binaries, into native binaries. All of this combined makes the perfect tool for building microservices, in my opinion. And Golang, from the past couple of years, has had a huge adoption into the web space. So building microservices with Go has been on the rise and will continue to rise. And as you're going to see in this course, we're going to implement hot reloading into our development flow, making our development way quicker. And because Golang compiles so fast, you're going to see that this is going to be blazingly fast to change codes, and we're going to save it and it's going to redeploy again, not redeploy, but the service is going to boot up again very quickly. And not only that, being into a multiple service environment where we need to do frequent deployments, being able to create a Docker image very quickly with the native compiled code makes it an even better tool to choose. Not to mention that unhealthy services, so if a service dies, it's going to be replaced by a healthy one, a new one, much faster because it's going to boot way quicker. Now, I just want to leave you, before we end up this video here, I just want to give you 2 resources to learn more about microservices, because this is a complex topic and I don't want to make this out of theory. I want to get my hands dirty, and as you do probably. So here is an article from Martin Fowler, which is one of the OGs of this architecture. This is a very good article. It makes references to other ones, so if you want to go really in depth, this is the place to go. And here on the right, I also have one from microservices.io, which is a very good one as well if you want to dive into this world. So if you're into the school community, I'm going to leave the links down below the video. If you're on YouTube, the links might be on the description as well. So building an order management system like McDonald's requires a lot of moving pieces, and we want to make sure that the system is scalable enough to handle the restaurant peak hours, right? So in this module here, we're going to design everything. We're going to divide the services and think about the different services that we need to build to create the user requests. And as we have seen in the previous module, microservices are a good candidate to build and solve this problem. So let's get our brains working and start thinking about the different pieces that make this system, from the lifecycle of the user making a request in the point of service to the kitchen being prepared, so the kitchen, the staff starting preparing your order until you get your order delivered. So let's start with the user. So he gets to the restaurant, he goes to the point of service screen. So it could be like, imagine those screens, you have a browser in them, right? So you're going to make a request to some sort of service. For example, we're going to have the order service first. So just a quick sketch. Then we're going to refine this. Now this order service here is going to be the central piece of our events-driven architecture, because from here everything is going to happen. We're going to dispatch the order creation event, which then is going to dispatch the payments. We're going to check the stock from here. We're going to do all of that. But first, we need to store these orders in some sort of storage. So that is what we're going to do. So this is going to have its own database. Now let me just add this one here. Okay, so this is going to be the orders database, and I'm thinking of making this MongoDB, like a NoSQL. Okay, we don't need the relational database for this, and when we deploy this, we can actually have a MongoDB database for free with Mongo Atlas, so that's going to be nice. Now, when an order comes in, we want to make sure that there is enough stock, so we need to validate these orders against a stock service. So let's just copy this guy here, and let's create a stock service. The stock service is going to be very specific, just going to handle the stock and all of that. So if you want to make sure an order has the right quantities, this is where we're going to go. And of course, the stock is going to require as well its own storage. So otherwise, where could we store this? And the cool thing about having a NoSQL database like MongoDB is that they are very lightweight, so whenever we boot our instances up with Docker and Compose, for example, they are going to boot up a little bit faster. Now, you might be wondering, why would we need two databases, right? Why would we want to have orders DB and then stock DB? Now, the reason for this is, as we've seen in the previous module, in the theory behind microservices and the good practices, is that the services should be really independent, and this also applies to their data. And if the stock service needs to access the orders database, which it shouldn't, if it does, what happens is that we send events instead. So we're not going to access directly this database, we're not going to have a central database, because this is against the point of having a scalable and independent system, because we want to make sure that the stock database does not have orders in it, it doesn't know about orders, just knows about stock and the items there. And as you can see, all of these services are very small. They do one thing very well, and they just do it. This is the instance of microservices. And if the project grows enough, we can assign one engineering team to each service so they can work independently. Now, before we add more services, let me add the gateway service. So the gateway is going to act as an entry point for our system. So instead of making a direct call to the order service, the user is going to make a call to the gateway, and that is the responsibility of the gateway to redirect to the right service. It will be responsible for handling HTTP requests, so all of these services are going to communicate by gRPC, and the gateway is going to expose an HTTP port to the outside world where the browser can make a request, and then the gateway is going to redirect or route the request to the right endpoint, or in this case, the right service. So here, for example, we could move our system a little bit here and make the gateway call the order service instead. So we have just introduced this middleman here. And another thing is that there's going to be multiple instances of these services. So here I have just drawn a square. But basically, what we need to draw here is that there is going to be multiple instances of the order services, of the stock services at any given time. So what I'm going to do is that I'm going to delete this here, and I'm going to add this drawing here. Basically, what it means is that it's for us to know that there's going to be multiple instances of each service at each time. So let me do the same for this stock. I'm going to clean all of this drawing in a bit as well, so it makes a little bit more sense at the end, because this is going to be our reference drawing to do the service, to the project. So let's add here another service, which is going to be the menu service. So this is going to be responsible for serving the menu. I'm still doubting if you're going to have this service or not, because we might just mock the menu hard-coded on the user interface, but we'll see about that. But if you want to implement this menu service, it could be really just a service that returns the menu for the screen, so the user can start the order, right? Now, all of this communication here that we have just done so far, I think it makes sense to be synchronous. So what I mean by synchronous is that we're not going to be sending events as of now, so we're not going to use the message broker. For example, the gateway can communicate via gRPC to the order service, and same like the order service can communicate to the menu via gRPC, just like to the stock as well. So there is no immediate need, in my opinion, to add asynchronous communication here. If there is, we can just do it later in the course, but I think we can move much quicker here by doing gRPC communication, and I also have the chance to show you how you can do that with gRPC. But the crucial part of this system here is when an order is actually created. So after the validation, after we get the menu, when this order is created, it's going to produce an event to the message broker, and then this is where the cool stuff starts to happen. The asynchronous part starts to show, because here on the payment service, this is going to be asynchronous communication. So to get to the payment service is going to listen for an event, which is going to be the order created, for example, and here is going to initiate the payment flow. And after the payment has been succeeds, we need to send another event to the system to tell the order service to update the order status and also update other properties to update the stock. So we need to decrease the stock quantities of the products that we have requested, and we need to update the kitchen service or the staff that the order has been paid and they can start making the order. And so here I have made 3 queues. So basically these are going to be the event queues that we're going to have. For example, you have the order created, the order paid, and the order updated. Basically the order service is going to send to this queue here the order created, which then the order service is going to listen. Now here on the payment service is going to interact with a processor. So in this case, it's going to be the Stripe processor. We're going to make this in a way that is abstract. So we can inject any processor that we want, any payment processor. We can even create an in-memory processor for testing, which is what we're going to do. And then after this, the Stripe is going to work like a webhook. So it's going to send a webhook to us, where basically we are updated that the order has been paid. After that, the order has been paid, we send to this queue the order paid, and this one is the most interesting because we're going to fan out this message to all of the services. So we're going to basically broadcast this message to multiple servers. The first one is the orders, the second one is the stock, and then the third one is going to be the kitchen service, which can be here isolated, right? And then the kitchen service after the order has been cooked. So he's going to receive this event here. He's going to start cooking. So we're going to create a long running process simulating the staff cooking. And then we're going to notify the user. So let me just copy here. So we're going to notify the browser that the order is ready for pickup. As you saw in the introduction, we're going to have that real-time pop-up showing. And then we're also going to update the order service. So I'm just going to copy the order service here so we don't make spaghetti mess of errors here. Basically, we're going to update the order by changing their status and all of that. So this is pretty much the high overview of what we're going to build. So here I just took some time to make everything a little bit more pretty so we can have this cool diagram, I guess. And basically this is what we have done, but a little bit more colorized and everything. So here we still have the gateway, which communicates with the menu service, the orders, and that flow here. So if this sounds exciting to you, this is what you're going to be building in this course. So I see you on the next one, where we're going to discuss what the services are going to do in detail. So let's quickly just go over all of the services and check what they are going to actually do in detail. So the order service is going to validate the order details. So what's going to happen is that the request comes in from the gateway, and then we are going to validate the orders. So basically we're going to talk with the stock service, for example, where we're going to check their quantities. And then the order service is also responsible for the CRUD of the orders. So it's going to create orders, updates, delete, all of that. And then it's also going to initiate the payment flow. So it's going to send an event to the payment service to start the payments. Then the stock service is pretty straightforward. It's going to handle the stock, it's going to validate the order quantities, and it might return items on the menu or not. So I have added this item here because we're not sure if we're going to implement the menu service to start with. So we're going to try to start simple, and the stock service might or might not return the items of the menu. We'll think about that as we go. Then the menu is pretty straightforward. So it starts the items of the menu, and then we have the payment service, which is going to initiate a payment with a third-party provider. In this case, it's going to be Stripe. And then we produce the orders paid or canceled events to the order, stock, and the kitchen service, as we've seen in the diagram. And then finally, the kitchen. And then the kitchen service is going to simulate a long-running process of a simulated stuff. So the kitchen stuff is going to cook the order, right? And then it's going to notify basically the system that the order is ready. And this is where the process of an order finishes. And I really just wanted to make this quick video, this quick end of the module, just to plant the seed in your head so that you know what you're going to be building, the decisions that you're going to be making, so that you can also advocate. And this is not placed in stone. This is not the best architecture. If you have any idea on any suggestions, you could go to the community and create a post, and we are going to gladly discuss, because that is how you're going to learn. And this is the reason why I have posted this course on this cool community at all. And as you go through the course, be free to make suggestions, because we might not implement a menu service, you could implement a menu service, you could implement something different, and if you do, share them on the community as well. So finally, let's get our hands dirty and start coding this whole thing. So here are the tools that we're going to be using in this project. You don't need to know them all. However, you should be comfortable with writing Go. You should be comfortable with the Golang syntax. Go is pretty simple and it's pretty powerful. But if you don't know the syntax, you're going to struggle, because this is more of an advanced course. Now, the good news is that if you don't know Go, you can go into the School Community Classroom, and there's going to be the 30 days of Go course. If you're watching this at the time that the course is still in the making, then you can go to my YouTube channel, where I have just a bunch of videos on Go that should cover you as well. Now, we're going to use Go 122 Plus, so we are going to be using the native routing that comes with this version. That is pretty nice. You should be comfortable with using any version upwards here. Then we're going to use the Golang Air for the hot reloading of our services, so whenever we make changes to our files, the service is going to be changed in real time. Then we're going to use gRPC for communication between services, so for intra-service communication. Then, as we have seen, we're going to use RabbitMQ as the message broker. You can use Kafka, you can use whatever, but if you learn one, you can use the other one, as long as you understand the fundamentals of a message broker, of an asynchronous message broker. And then we're going to use Docker with Docker Compose. You should have Docker installed on your machine. Docker and Go are the only requirements that you need to have installed as of now, because most of these tools are going to run on Docker containers, so that is why you should have Docker installed. If you don't, just go on Google and type Docker and you can quickly install Docker for desktop. And then you're going to use MongoDB as a storage layer, and Jaeger for service tracing. We're going to have Jaeger UI there. And then we have the HashiCorp console for service discovery. At the end of the course, if you're watching this, there might be the Kubernetes addendum, which there we might implement service discovery with the Kubernetes instead of using console, but for the whole bulk of the course, you're going to be using console. And then Stripe for payments. This is what you're going to use for the payments of the orders. So here I'm at my desktop, and let's create a folder for our project. So I'm going to call this Order Management System V2, because I already have an Order Management System V1 before, which was an introduction lesson on YouTube. It's for free. It's a gRPC course there. So I'm going to call this V2 because I'm going to be using I'm going to push this to GitHub, so I don't want to have any conflicts there, but just could call it anything you want. Then I'm going to open this in VS Code. So here I'm at my editor, and before I start creating our folders, I just want to show you what we're going to use, because the folder structure that I'm going to use, it really doesn't matter what it is, as long as at the end we can have our microservices independent. And I'm going to use a tool called Go Workspaces, which comes with Go. If you're not familiar with this, it's a way for us to quickly create a development monorepo, meaning that the dependencies of each microservice can be reusable across the whole project. Meaning that I can come here and create like the payment service, can create the order service. Actually, I'm going to put this into a plural, payments, and then I'm going to have a common package. This is going to be reusable functions across the whole services, so we don't have that much duplicated codes and features. And then we're going to have the stock service. We could also have the gateway, very important. And finally, just add the kitchen service as well. And then all of these services are going to be, it could be whatever you want. You could have independent GitHub repositories, and then you could deploy them all. What I'm going to do is that I'm going to have a Go workspace, and I'm going to show you how. Go work init. But actually what we need to do first is go to each service. So I'm going to go to the common, and then we need to do a git mod init before we do the Go workspace. So I'm going to call this one with my GitHub handle, and then the name of the project, which is going to be, actually this is going to be just comments, because this could be a separate repo at the end. Then I'm going to do the same for the rest of the modules. So the gateway, in this case, is going to be the name of the project with the gateway suffix. Then let's do the same for the rest. Like so. So I'm just going to skip forward and do the rest of them, so you don't need to watch this. All right, so there we go. We have the Go modules for all of the services. Let me just check the gateway it has. So now let's do a Go work init. And basically, we just need to say which are the services that you're going to have. So it's going to be the common, the gateway. I'm going to have the kitchen, doing them in order, then the orders, the payments, and also the stock as well. So here we have a Go work file created. And if you check it, here are all of the services that we have created. If you want to add something here, you can just do like the menu, and you don't need to update it anymore. So just do this. You get an error because it doesn't exist. So it must have a Go mod in it to be valid. And basically, if you are unfamiliar with Go Workspaces, I'm gonna leave this link here below the video. This is from the Go dev team. Basically, this is the way that Go Workspaces work. If you're not familiar with it, you could give it a read here. It's pretty simple, so there's not much to know, but if you want to go ahead, I'm gonna leave it anyways. All right, so let's start by creating the order service. We're gonna start with this one. I think it makes sense. So first, let's create a main.go file here. So it's going to be on the package main. And I'm just going to create here a quick function so that we can have everything started. So the first thing that you need to know is that our microservices are going to be simple by design. I'm not going to make any big folder structure. This is because I don't want to be opinionated. I want you to be able to choose what you want for your project, but we're going to take bits and pieces from the clean architecture. So we're going to create a layered architecture. So we're going to have the storage at the bottom. We're going to have the service, which has the business logic. Then we're going to have the transport layers, and we're also going to have a gateway layer, which basically it's going to be responsible for the service discovery and the connection to the right service. So we're going to see all of that separated beautifully. It's going to be awesome. And then we can also test everything because everything is going to be nicely separated, and we're going to see that. So first, let's start by creating, for example, the service.go. And then I'm going to also create a storage because we're going to store the orders. And then we should also have types. So this is going to contain the interfaces. So let me just create here the order service interface, and then you can also create the orders store interface. So we can just start by having the create order, very simple here. We're going to come back and change this, of course, but for now we're just going to send the context because we need to create the payload and the output, which are going to be gRPC generated code. So for now, let's just have this and return an error. And here on the storage, you could have create as well, or you could take as well the context. So I'm just going to copy this here and call this create. Then here on the service, I'm going to create just a struct called service. This is going to implement the interface that we have just created. So this is going to have the storage. So I'm just going to call it store. It's going to be the order store. And then I'm going to create a constructor, new service, which is going to take the store, has a dependency, the orders store, and it's going to return a pointer to the service, for example. And we can just return like so. A new instance where you just pass in store, right? So now to implement this interface, we need to have the create order method. So let's do that. It's going to be a method of the service. Just like so. And here you can just return nil for now, just so we can bootstrap everything up. And I'm going to do the same thing for the store. So I'm going to have a type, which is going to be the store. And for now, we are not going to have any dependencies. In the future, we're going to add here our MongoDB instance, but for now, this is fine. I'm going to also create a constructor for the store. Like so. And the method as well, which is the create. All right, so we're going to have here an error. I need to return an error, so I'm just going to return nil. Now here on the main, let's start everything. So I'm going to have a service, just call this new service. It's going to have the business logic. Then we're going to have the store, which is going to be new store. I'm going to pass in the store to the service. and this is going to be it. So here on the main, we're going to have the transports and the basically going to initiate everything. We also need to initiate the transport, which is going to be gRPC, but we get that into the next module. So for now, this is going to be it. And then you could call, for example, the service.create order, where you could pass the context.background, for example, just so we don't have an error. All right, so for now, let's leave here the orders.main. We got introduced to the layered architecture that we're going to use on all of the services. So all of the services are going to follow something similar. We're going to build upon this later. But now let's go back to the gateway and implement the entry point of our application, where we're going to create an HTTP server. And then on the next module, we're going to create a gRPC into our system. Then we can communicate via gRPC to the order service. All right, so here we are at the gateway service, and the gateway service is going to be the most simple one because we're not going to have that layered architecture per se, because first, we don't have business logic, so we're not going to have a service. We don't store anything. We don't have a storage layer. We're just going to have a transport layer because the gateway is going to act as a load balancer to our services. It's basically going to expose an HTTP server, and then it's going to implement a gRPC connection to those services via gateways, right? So first, what we need to do is create that HTTP router. So I'm going to use Go 122, the vanilla HTTP routers here. If we can add She or any other package later, but for now, this serves our purpose. And then we have these mugs. We can just do handle func. And here is going to be the signature to create the first order. It's going to be /API. So it's going to be customers /customer ID. We need the customer ID. And then the resource is going to be the orders. And then we just need to have here a handler with a handler func to handle it. What I'm going to do instead is that I'm going to copy this out, and I'm going to create a file here called http.handler. So this is going to be the handler for the HTTP layer. Let's just call this main. And then here I'm going to do what I usually like to do in all of my videos, which is having a handler type, a struct here. And then again, this is going to be just a constructor here. Let's call this new handler. It's going to return just a pointer to handler. Just like we've seen before. This is going to take in the future dependency, which is going to be the gateway. So the gateway is going to be the layer of the service discovery. So we're going to keep that in mind. And then let's just have here a method called register routes. So this is going to register all of the routes here. It's going to receive a mux, which is going to be the HTTP serve mux, like so. And then this is not going to return anything. We can just have our signatures here. And then down here, let's have our handle create order, which is going to receive a request writer and a response. So if you check here the handler func, it needs to receive the response writer and the request. You should be familiar with this by now, but just to reiterate as well. Then I just come here and I call the handle create order. Then here on the main, all we need to do is create the handler. So I'm going to call this new handler. And then we do handler dot register routes. We pass in the router. And then at the end, we need to start the HTTP server and pass in our handler as a parameter. If errors from the http.listen and serve, we pass in here the HTTP address and as well as the mux. Then if the error is different than nil, we need to handle it, which all we're going to do is log.fatal failed to start server, for example, HTTP server. And here I'm going to create a variable here called HTTP address. This is going to come from the environment variables in the future, but for now, let's just have it hard-coded here. This is the ports that we're going to have. Now let's actually test this. And what we can do with Go Workspaces is go back to the root, and we can just do go run, and then the name of the service is going to be the gateway. And here we have our HTTP server listening. I just want to add here a log so that we know it is running. So just like so. Okay, so if we try again to run, we should have the go run gateway. We have the starting HTTP server at 8080. Awesome. So we just have an HTTP server created. So let's go ahead and maybe think about creating a gRPC connection. So basically here we have the whole boilerplate for the gateway and the service. Of course, we're not calling the service here because we require the gRPC to do that. This is what we're going to do. So this is going to be pretty much it for the gateway right now. So before we finish this module, I just want to show you two things. The first is going to be the comments package. So we're going to create and initialize the comment package because this is going to allow us to have reusable functions across all of the services so we don't repeat ourselves. And then at the next video, I want to show you as well the hot reloading feature that we're going to implement. So we can have all of that boring stuff set up out of the gate so we can start building fast. So the first thing is that I'm going to create here maybe env.go because we should have a way to get environment variables from our services as we saw here. It would be nice to have a function that would get this environment variable, and if it didn't exist, it would use a fallback value. So that is what we're going to do. So here it's going to be inside the package common instead of being main, and then let's have a function called env string. So this function is going to receive a key and a fallback. So the first thing you need to do is go to syscall dots, I think it's called get env. Here receives the key and it returns a value and a boolean in case if it's found or not. So we can just consume this here. If it is okay, we just return the value. Else we can return the fallback like so. Now to consume this, let's go back to our main here on the gateway and let's do a common. We should have here the autocomplete. If not, we can just import it directly like this. And then I'm going to do is env string. This is going to be the HTTP other. And then the fallback could be the 8080 like so. And of course, now this needs to be a variable, not a constant. So let's just change that. And actually we could come here and actually implement the reading of the environment variables. So let me create here .env file. And what we're going to use is this package called go.env. This is the de facto standards to use to load environment variables in Go. At least it's the one I see the most. You can do it like this, or I'm going to do it like so, because let me just show you why. Here we have our variables declared here, which are getting the environment variables. So we want to make sure that this package is loaded before the that function is called. So that is how we can do it. Then what I'm going to do is, once we have this fallback 3000, and I'm going to create here on the variables gdp.other, and I'm going to be 8080, and I just want to see that the file is going to read the 8080 and not the 3000. Then I'm going to change this back. Now what we need to do, I think, is if I run this from the root, this is not going to work. Yeah, it's picked up the 3000, so it didn't read the file, because when you run this from the root, it's checking for the .env here, and this is not how we're going to run our projects. So let's go back to the gateway and then do this again here. Now we need to do like so. So as you can see, the .env loading is working. Let me just revert this back to 8080, like so. All right, so what we're going to do now is implement the hot reloading feature to our project. So what I'm going to do is use this package called air. So this is going to enable us to, it's basically a CLI tool that's going to enable us to watch for changes in a file tree, and then it's going to hot reload whenever there's a change in the files that we are encoding, as you can see here. The way that you install this, you need to install this on your system, depending on the system that you have. Basically, you need to install the CLI. I already have it installed, so I'm going to skip that. If you want to install, I'm going to leave the link below the video, or you can just search for Golang air in your browser and you can get here. Basically, you can even run this in the Docker container, which is pretty nice. So let's copy this command here, the air init, and let's go back to the project. And here, let us go to the gateway, and I'm going to do the air init, which is going to start and create this air.stoml. This is going to be the configuration files that we can define the configuration for the air hot reloading. So the default configuration, I think it's fine. We don't need to change anything here. So if you go back to the terminal and now run air instead, we can see that the project is running. And if we for some reason do any change here, so let's do log here, log.print We just close the terminal, print ln hello. If we save this, you can see that the changes has been found. Basically, it found changes in this file, and then it's going to hot reload the server again. So if I just delete this again and save it, it's going to do the same thing. So this is going to speed up our development flow by a lot. So this is pretty much it for this module. I hope you guys are liking it so far and you are excited, because on the next module, you're going to take on the gRPC configuration. We're going to explore the world of intra-service communication, and we're going to implement the gRPC transport into our two services. So let's go back to our diagram that we did on the previous modules. Basically, I want to show you quickly the difference between asynchronous and asynchronous communication. So we're going to implement synchronous communication first. This could be with HTTP, gRPC. We're going to use gRPC, and this is useful for cases where we want an immediate response from the request. So for example, here we have the gateway, and when the user requests for an order, so he's going to create an order or he's going to fetch one, basically we want to talk to the order service and get an immediate response here, so that we can just respond to the user with the order, right? There is no need to send an event just to fetch an order or to create one. I mean, to create one there is, but it's only here because you see, we can create the order, we can store it, and the status is going to be pending, it needs payment. But after that, the order service is the one responsible for sending an asynchronous message to any other service that would like to do something with the order created. In this case, we have the payment service, which is going to start the payment flow. So for that flow here, the first one, the blue arrows, this is going to be gRPC, which is going to focus on this module right now. So why gRPC in the first place? Why don't we make all the server-to-server requests with JSON, for example, since we are so used to it? Now, the first reason that I chose gRPC is because it's more performant, so we can reduce the latency between the server-to-server communication, which it is important, and we're going to leverage that. And then another reason is the strongly typed contracts. Basically, with proto buffers, we're going to be able to have strongly typed contracts, meaning that we're going to use the commons package to have all the types there, generated code, and then we can just reuse across all of the services without having any inconsistency between them. And then, of course, protocol buffers are more efficient than JSON. This is binary format. JSON, we have to do the parsing, the encoding, and all of that, which is going to be more expensive to do. And then this is one of the best candidates for server-to-server communication. So we're going to use gRPC over JSON. However, we're going to have a JSON API, as we have already built, for the gateway to communicate between the browser or the clients in this case. So back in our code, let me first show you the protocol buffer syntax so you can have an idea. And if you want to explore more, if you want to do something different that I'm doing in the video, you can explore here the protocol buffers. Just type protocol buffers in your browser and you should land on this page. Basically, here you can define, for example, a message, which is like a Golang type, for example, and you can have the options here. This is what we're going to do. We're going to go here to the common. Let's create a folder called API. So API is going to define the signature for our gRPC API. And in here, let's call an order management system.proto. And if you don't have this icon here, or if you don't have the language server, I think if you are on VS Code, all you need to do is just download the extension. Just write, let me actually show you. I think this is the one that I'm using. It's the one that I have installed and has a bunch of downloads. So I think this is the one to go. And after that, you have installed it, you should have syntax highlighting here. Now, the first thing that I'm going to do is I'm going to say that the syntax is going to be proto3. And after this, we should have the syntax highlighting now. And I'm going to say this is my Golang package. So we need to define this here as well. And then I'm going to also define here package called API. And then here, let's start by defining our service. This is going to be the order service. So let's just call order service. And then here are going to be RPC methods that we can communicate between services. So the first one is going to be the create order. And it's going to return something. And here we need to add the semicolon because that is how it's done. And here basically we need to add two types. If I save this, I get an error. Basically, we're going to go back and create a message as we saw here in the documentation. In this case, I'm going to call this get create. Actually, it's going to be create order request, for example. And then we're going to receive a string, which is going to be the customer ID. And then we should also receive, actually it's going to be a new message, so it's going to be a repeated. I'm going to call this items with quantity, and it's going to be called items, like so. So this is going to be a new type, so I'm going to call this here message, items with quantity, and it's going to have an item ID, which is going to be like so, a string, and then we could have the quantity, which could be an int 32. I'm going to call this quantity, and this should need to add here the create order requests, and then let me also create the response. Actually, let's just return an order. I think it makes sense. And here let's define the order. This is going to be a very important type. It is going to have an ID. The reason I'm making these ID strings is because they are going to be MongoDB IDs, which are going to be like those hashes, if you know what I mean. And then we have the customer ID as well. We could have a status. Then let's have a repeated items. It's going to be items. Now there is a difference between items with quantity and items, because the items, I want them to be, they're going to have these options here, but they're also going to have a price like so. It's going to be price ID. Now the reason I'm just moving a little bit ahead here, because I know that we're going to use Stripe, and the way that we're going to implement is that we're going to have a string, which is going to be the price ID there. So we know we store that in our database. And we could also have a name for the item. I think it makes sense. Let me just add this one more. And then here we have items. Everything is good. If this is returns. Items, it's in the singular. And I think we have everything that we need for our first RPC method, the create order. So let's generate this into Go code. So here I'm at the gRPC documentation for Go on the quick start. If you want to reach here, just go into your browser and type Golang gRPC, or I should leave a link in below the video. But basically, if you don't have gRPC CLI in your machine, you should install it like so. And then I already have it on my machine, so I'm not going to do that. And basically what we need to do after is go back to our codes, and we need to run the protoc CLI. What I'm going to do is that we're going to run this a couple of times. So I'm going to have this on a Makefile, so we can reuse this every time and we don't need to remember the command. So I'm going to call this gen. Then here on the documentation, we have the regenerate gRPC code. This is the command that we're going to use. So let's just copy this guy here. And what we need to change is here, it is on /API, and we want to target the OMS.proto file. Let's try this out actually. So let's go to the comments and let's do make gen. And here we have everything generated, so it works. And here we have this code. We should not touch this code. This is code that we generate from this file. So if we want to change something, we come to this file, we change it here, and then we run the command. We should not change anything here, otherwise there might be problems. One thing we need to do here is I'm going to go to this one and I'm going to install this package. So because we're going to have some errors here, so let's just go get like so. And let's see if the errors are gone. So the errors are gone. They all depend on that one. So that is how we do it. So basically we have gRPC installed into our system. Now what we need to do is actually consume this code from our gateway service, for example. So let's do that now. So here on the main, I'm going to go to the register routes and inside of the handler. So let's actually come here. And the first thing is that we need to import these files on the common, on the API. So here what we need to do is I'm going to call this protobuf, so PB for short, because we're going to manually import this package from here. So it's going to be on this path. So it's going to be the one that you have written. For me, it's going to be commons. I think that is what I called this package, commons. And then it's going to be under the /API. And if you get here an error, you need to import that. And here below, you have access to everything of the generated code that we have just generated. So everything here, what we're going to do is that we're going to create a new client. So let's just search for new client. It's going to be the new order service client. And here we need to pass in a connection. Now to receive a connection here, I don't want to establish a new gRPC connection every time we create an order. Basically what I'm going to do is that I'm going to do that on the main. We're going to refactor all of these when we introduce the gateway transport, because when we have service discovery, this is going to be encapsulated away from us. But for now, I want to move theirs gradually. So let's do here on the main. What I'm going to do is that I'm going to have a connection and it's going to return an error. I'm going to do the gRPC.dial. I'm just going to save to import the gRPC package, and then here what we receive is we need a target and options which we need to pass. So the first one is the order service. So this here is the address to the order service. So it's going to be hard-coded for now, and as you can see, if you already think about what we have explained before, this is going to limit us because the gRPC service is going to be an address. So I could actually call this other. And then I'm going to put here, let's call this, like, for example, localhosts 3000. And the reason this is a problem is that we are just targeting one server, just one instance of it. And if, for example, this server dies or it's not running on this port, then we lose the connection. That's why we need to create a new abstraction layer here so that we can find multiple instances of the service, of the order service, so we don't depend on this hard-coded address here. Then I'm going to add something here, which I think we need, which is the with transports credentials. And here I'm going to use the insecure dot new credentials, like so. Now let me just defer the connection of the, this is not an error, this is the, is it? So let me actually see. It is an error, yes. So we need to do defer dot connection dot close, like so. And I'm going to handle the error as well, like so. And then I'm going to just log here that the server has started. All right, so now what we can do is come here, and I'm going to move back this to here as well. So I'm going to call this the clients, and I'm going to save. I think it imported correctly. Yes, it did. So what we can do is can pass here the connection, it accepted, and I'm going to send this into the service to the handler. So the handler is going to receive this guy here, which is order service client. Now here, let's update it as well. I'm going to call this clients, and we can do this as well on the constructor, like so. So now here, what we can do is we can just access the handler.clients.create order, and here we can pass in the request.context, for example, and here is the payloads. So let's just try this out. I'm going to send a customer ID of, actually we can just read from the parameters here, so no need to create mock data. So request.path value, customer ID, and then we can just pass in the customer ID like so. What do we need more? We need items. Now for the items here, I will just do it like so. So the problem with item is that they are going to be sent through the post request, so through here. So we need to unmarshal that into JSON, and then we can send it here. So let's create a couple of functions here. Actually, what I'm going to do is I'm going to create a file called JSON here, json.go. Okay, so I have just moved that file here to the comments, so we can actually use that across multiple services. So let's actually implement this. First, I'm going to create a function called write.json or Marshall.json, which is going to receive a request, response, I mean. So it's going to be the response writer. And then this is going to receive data. Actually, I'm going to receive first the status. It's going to be an integer, and then the data, which could be anything. And then we just return. Then I'm going to set the header as JSON. So it's going to be application JSON. This is how it, no, it's contents, content type. And then here it's application JSON. Then I'm going to write the status to the header. Then finally do json.new encoder. We encode to the response, and then we encode the data, which is going to be data, like so. So then we can just have this function here. Now we need a function to unmarshal the JSON. Pretty similar here. So instead of having the encoding here, we are decoding it from the body into this data interface. So this actually could be here and any as well. And then I'm just going to write another one, which is going to be the write error. It's going to be pretty useful for us, which basically what it's going to do is going to call the write JSON, but it's going to return an error. And then basically on the data, what we're going to return is a constant output. Basically, the consumers of our API are always going to receive an error in the same format. This is why I like to create this function. And here is going to be the message of the error. So they are going to receive this JSON structure with an error like so. So it would be like error. And then you are going to have the message here. Like so, any front end consuming this can expect an error in the same formats. Now let's consume this here on the handler. So we're gonna have items, which is gonna be the pointers to items with quantity. This is gonna be a slice. Then we're gonna read this from the common dots reads JSON. Here we're gonna pass in our requests, the data, which are going to be the items, and then if the error is different than the nil, we should also return and send an error to the user. So we're going to use the comments again, dot write error, and then I'm going to send an http dot bad requests, so the user knows that this is a bad payload, and then the message could be just error dot error, like so. So now we should have items here that we can send to our gRPC. So this is pretty much it to consume it. Now we need to create the server. So I kind of started the inverse order because we need to create the server here on the orders so that it can receive that request. So let's do that as well. So let's go here to the top. What I'm going to do is that I'm going to do a server, so it's going to be gRPC server. I'm going to call gRPC.new server, like so. Now let's go to the end of the file and let's listen. If error from the gRPC server.serve. This is a listen other that we need to pass a connection, a TCP connection actually. So let's just finish this and we're going to pass it in. I'm going to do log.fatal error.error. Then here we need, so here let's just do that. So it's on the net package. So it's going to be new dial TCP, and this is going to be the address. So the address is going to be gRPC other, which is going to be an environment variable. And we forgot to actually add the environment variables on this service. We're going to do that as well. So let me just do common.env string gRPC other. And this could be local hosts 2000. I think we said 3000 here. Yeah, we said 3000. Let's actually move this to 2000 and then we keep it like so. And this is a typo here, gRPC. We pass the header here. Let's handle the error. Let's then close the connection by deferring it. And now we can just pass it here. I forgot this is not now, this is a listen, like so, my bad. Now what we need to do is create the handler. So basically we need to create or implement the interface to create the orders. I'm going to show you this now, it's going to make more sense. So here on the, actually we don't have a handler layer. So let's create here a file called grpc.handler.go. You can just make it here. Now this is going to be of the type gRPC handler, for example. It's going to be a struct, and this is going to implement a very important interface from this PB module. So let's just import it here because it's not liking the autocompletion. I have a typo here, so that is wrong. Basically what we need to do here is search for the unimplemented order service server. So if you check this out, basically this is a struct which implements this interface, this one here. If we implement this, then we are a valid order service server. So all we need to do is copy this here and implement this function. If you add any methods in the future, you need to add them here. This is how you're going to handle. This is going to make sense when you make the request. So I'm going to call this gRPC handler instead. And then this is going to be coming from the PB as well, from the proto buffer definition. I'm going to save, so to import everything. And then here, let's just log.print when new order received. Okay. And I'm gonna just return, actually we need to return something here. So let's do, just to test this out, I'm gonna create a dummy order, like so. And I'm gonna call this 42. And we can actually just return this and a nil. Let's save this, let's go back to, let's create a constructor for this actually. So new gRPC handler. Just going to return the gRPC handler. And it's going to receive the connection. Or no, we don't need to do anything of that. What we need to do here instead is create this server. So let's do pb.newServer. And here, this is where we receive the gRPC server. So we need to pass it here instead, not in the handler. And then this is going to be of type grpc.server. So let's just paste that in. We have that here. Now we need the then we need the handler. So what I'm going to do is that I'm going to create the handler up here, handler, and I'm going to pass that in there. And actually we don't need to return any instance of this. We can just remove that. Now, the reason we have this error here, I see. So this is not the right thing. It's the register order service, and here we pass the handler. Now, why is this? Because if you check this interface here, this method, it receives an interface, and this is the interface that we are implementing. If for some reason we change this type here, then the interface does not implement, so we get that error there. So this is the cool thing about a Golang interfaces, of course. And now let's go back to the main. I'm going to do gRPC or new gRPC.handler, pass in the gRPC server, just like so. And now whenever we boot this server, we have a gRPC listening. So let's test this out. I think we can test everything. So let's just go back to the orders. I'm going to do R. Actually, I've forgotten to add the R init on this service. So let's just create that file. Let's R now, and it should work. There we go. I also want to add some sort of feedback here. So I'm going to do log.printf. I could just do a print ln here as well. gRPC server started. Add, and then we put the gRPC address, like so. So let's just do this again. And here we have the server running at localhost 2000. And if we go to the gateway, let's test this out. I need to run the gateway as well. And then we need to make a curl request to this server. So we can also see that dialing orders at service. So this has been successful. So the gRPC client connected to the server. So let's do the curl request. What I'm going to actually do is I have just opened here my HTTP like Postman program. So I have this thing called standard clients. You can install in your VS Code if you want, or you could just use Postman, whatever suits you best. So let's try and hit send. So we got to 200. Let's see the terminal. We have a new order received, and if we hit it again, we can see that we are having a client to server communication. Let me just do a log on the orders to see if we are actually receiving the payloads. Let's go here to the handler, and let's print this out here. Actually, I'm going to do it here. Let's just do a print f. I'm going to do orders. And then I'm going to just pass in dots. Actually, I need to do, let's call this context, and this is going to be the payload. I'm just going to call it P for shorts. And then let's do just like so. The server should have restarted with the hot reloading. This is awesome. Let's do the request again. And here we see that we got the customer ID 2 and the items as we have said here on the payload. So this is pretty much it for the intra-service communication. We're going to expand this more as the course goes. On the next module, we're going to implement service discovery, which is going to be pretty nice because we're going to encapsulate this layer. We won't have to do this kind of things where we have the address manually here. This is something that I was thinking of doing later into the course, but I decided to make it now so that we don't have to do this every time we want to connect to a gRPC server. Alright guys, just before we go to the next module and explore the world of service discovery, let's just first handle the payload validation both on the gateway service here and then on the orders as well. I want to do kind of a double validation, basically because we don't know if the service is going to be always called from the gateway. Another service might call orders. So I just want to make sure that we have here, it's going to be different validation as well, so it's going to make sense. So basically, I don't want to overcomplicate this. I don't want to install any packages for validation. I'm going to leave that to you if you want. I'm just going to have here a very simple function that is going to validate the inputs. So I'm going to have something like this. So I'm going to return an error. I'm just going to call this validates items. And then I'm going to pass in the items. And then down here, I'm just going to receive the items, which are going to be a slice of a pointer dot items with quantity, and it's going to return an error. So the first thing I want to do is if the length of the items is actually 0. If it is, then let's just return an error. Just like so. Items must have at least one item, and if it's wrong here, just going to return nil, like so. I'm still a bit rusty, not gonna lie. So now what we need to do is loop over the items. So I'm gonna range over them. And the first thing we're going to do is check if the item item.id is equal to an empty string. If it is empty, then we don't want this item here, as well as if the item.quantity is less than or equal to 0. We don't want to handle 0 items. Then we can just return errors.new. Items must have a valid quantity. So this is pretty much it for the validation I want to have here. So let's just consume the error. So I'm just going to do it in line. The error is different than nil. Then let's just return and return a body request like so. And then at the end, since we're here, let's just return to the users a JSON, because if we check what we did here, we returned a 200, but we did not return anything to the user. So let's just do that really quick. So this is going to be status OK. But I could even do, I'm going to do, okay, I could do a created, but let's not use much energy on that. And here I want to get the order created and also an error, because we're not doing that, like so. Actually, what does this return? It returns an order. It's writes JSON, my bad. Writes JSON. We send in the order. Let's handle the error. And here I'm probably just going to do this, but I'm going to return an internal server error, just like so. Basically, this is it. We need to handle this error a little bit better because this error is from an RPC call. Actually, I can do it here, I think. Yeah, so I'm gonna basically show you how to properly handle gRPC errors. Because if I show you here on the RPC, we're not returning any error, but if I come here and I return, let's just return an error just for you to see some errors. So let me just do fempty.errorf, some errors. And if we test this out now, so we have our server running. If I do this, as you can see, the error message has an RPC error code with ever the message we have. And even if we want to extract the status code, we cannot because this has a layer of the gRPC package around it. So we need to properly handle this. And this is what I'm going to show you now. So let's just get the errors. I'm going to do error status, or what can you call this? This is coming from status.convert, like so. I pass in the error, so this is going to be, so this returns status.status. I'm going to just call this our status, like so. Now what we do is if the error is different than nil instead of the error, then what you're going to do, so if the r.status is .code is different than codes invalid argument, for example, if it is, then what you can do is just return here, and we can do comments write error, and we pass in the has a bad request because this might be from the validation of the create order. If it's not, we're gonna just use the flow below, and here we can just do the error.status. This is the trick that we can do, which is the message. I think this is the one. So here we get the actual message without that prefix with gRPC. So let's actually test this. And as you can see, we just got the message without the gRPC, and we also got the right code, right? So this is how we can properly handle errors in gRPC. I'm just going to remove this here because we don't want to do that. And if we try again, we can see that everything works. We got even the payload of the order created because we are just adding the ID. We could even just return the order, I think, like so. No, this is a different type. But okay, so this is pretty much it for this. We should also handle the validation here on the create order. So what could we do here? We could, for example, we could start the bootstrap of the communication with the stock service, because this is going to be the bulk of the validation of the order service. When you receive an order, you need to check the quantities, and we also need to do something important, which is merge the items quantity, because if you look at this, on this payload, we are sending duplicated items, and we want to merge this into one, because we're going to see when we send this to do multiple computations in the stock or even on the payments, this is going to act as a different item in the loop. So we could just optimize this a bit and just merge those things together. Even on the payload, on the output for the user is going to act a little bit better. So let's do that here. Basically, I want to have, do we have a service here? We don't have the service layer injected. So let's actually do that. So let's go here to the gRPC handler, and let's require this service, which is going to be the orders service. and then I'm just going to pass this to the constructor as well. And then we pass into the handler just like so. Now we have access to the service, but we need to implement the methods here because we just have a create order. So let me just create here a method called validates order, which could just receive the contexts and an error. And we need to receive the order input, which is going to be, I need to import it from here, copy it from here. And this is going to be the create order request that I'm just going to send into the types. So it's not going to be a slice like so. This is a pointer. Now let's just copy the signature. Let's come here to the service and implement this new method. Now we could check here as well for the length of the items, because we should not proceed anymore if we don't have items to validate, right? So let me just do items is equal to 0. Then here we can just return an error. And what I'm going to do is that because we have this commands package, I'm going to move this error that we have just created here on the validation, and I'm going to move this here to a reusable error. So I'm going to just call this common error no items. And then here on the comments, I'm going to create a new file called errors.go. And let's just return all of the errors here. So error no items. We hit save. We have this reusable error. For now, let's just keep this one. If we need to have more, we can just add them like so. Okay, so we just validated that the items could be empty. Now let's just merge the payload items into just one. So this is going to be a function here, something like this, because we are receiving the payload with the items with quantity. So we need to pass those in, and this is going to look like something like could just do the items or merged items, better yet. Merge items quantity, we pass in the items, and here we need to implement this logic. So let's do that. So let's just start with the merge, which is going to be a slice of this, right? And then let's loop over the items that we have. Like so. Then at the end, we just need to return the merge. And basically, I'm going to fast forward a bit on this implementation so you guys don't have to see me thinking here. You can just copy this code, and then we just append the merge with the item, like so. And this is pretty much it for the implementation, guys. I know I have skipped this, but I don't want to make this video way too long, and this is not part of the core of the course. I just want to have this function so I have everything tied up. If you want, you can pause the video now, or you can get the source codes as well in the GitHub. So let's move on with this. And now that we have the merged items, we need to somehow validate with the stock service. Right now, stock service does not exist, so let's just keep this here. And we need to return an error, so I'm just going to return nil for now. I'm going to just log these items here, like so I don't have an error. And now we have an error here on the main, so let's see how we need to pass in the service. That's it. So this is pretty much it for this module. I just wanted to make this quick video for the validation of payload, so just that we have some ground coverage and infrastructure for the future. Now let's move to something different, which is the service discovery. So the problem that we are having now, and that we're gonna have even more into the future of this course, is that we are coding the addresses of the other services. For example, whenever we connect to the service, to the order service, we have it hard-coded. And this works fine if we have everything in one machine. But as we want to scale our application, running multiple servers, this is going to be a bottleneck. Not only that, but because we can only connect to one instance at a time, because there is no way to have multiple instances connected like this unless we hardcode another server here, which, as you can see, it's not a good option. I've also moved the servers that we're running to a different terminal because here I can create multiple panels. It's going to be easy for us to see. But as you can see, we are directly connecting to the order service, to the gRPC part here. Now, this is where service discovery comes, because the first thing that service discovery is going to solve for us is the ability to discover services that we have up and running. It helps us to add and remove services to our registry. And then finally, it also helps us to handle unresponsive services that we might have. So if the order service here is with problems, the service discovery is going to handle that for us. So we just need to focus on the business logic and not on finding the right service, right? So in simplicity, basically service discovery, you can just think about it as a registry. That is what we're actually going to create. We're going to create an abstract registry, and then we're going to create implementations. So we can think of a registry that stores information about the services, their addresses, all of that, and they have an ability to register and do health checks just to see that they are healthy. And there is two types of service discovery. There is client-side and server-side service discovery. We're going to implement client-side because it's going to be easy, and you can actually see how this is implemented, because on client-side, the client directly connects to the service discovery. On the server side, it's a load balancer that is going to redirect the service discovery, right? You can imagine the application that you're going to use, the software you're going to use is called Console, which we are going to implement service discovery on the client side. And then Kubernetes, you can imagine it could do on the server side.